Hello everyone, welcome back to the channel. And if you are new here and for the first time, then a very warm welcome. Okay. And in this video, we're going to build a RAG-based LangGraph AI agent. Okay. So let us first show you the demo. What we'll be doing. Okay. So I have enabled the web search, and here I'll be uploading my document to my knowledge base. And for the vector database, I am using Pinecone database. Okay. And for embedding model, we are using HuggingFace sentence transformer model. Okay. Now I'll upload this particular PDF, which is a literature survey on various image encryption and steganography techniques. Okay. I'll upload the PDF. It will take some time to chunk it, then upload its embedding vectors into our Pinecone database. Okay. Alright, so you could see that uploaded successfully, processed 5 pages. Okay, now I'll ask some question about it. First, let us ask some simple question. So, hello, enter. You see, hello, how can I assist you today? Now, the reason I've told you that it's an LangGraph AI agent, so we should see that how the agent is working under the hood, and that's why we have created this agent workflow trace. Okay, so it's saying that to answer this particular query or this particular message of user hello, it's just using only one router. Step 1, router description, router decided end node, decision end based on initial query analysis. Okay, now I'll be explaining you all this end router in our coming up modules. Okay. All right, now I'll be explaining you all this end router components, but it's just to give you the demo. Okay, now the PDF we have uploaded, to ask some questions about that, I'll ask some question that what is, let's say it was an image encryption, right? Image encryption. So let's say what is image encryption. Based on the provided context, image encryption is a process of converting a digital image into a blah 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 blah. Okay. And so based on the provided context, image encryption is a process of converting a digital image into a format that is unreadable and other things. Okay. Now here if I see this trace, you could see the step on router decided RAG, which is our first node of our agent. Okay. Now second node is our RAG lookup, where if you see the description, that RAG lookup perform content found and deemed sufficient. Okay, now here the RAG verdict. So we have a judge LLM and which will act as a judge that the query that user is asking, um, is my agent is enabled to retrieve the information from our knowledge base. If it does, then it will give a verdict as okay, it is sufficient relevant information found in our knowledge base. Okay, then our final step is our those answer node, where we'll be calling our LLM to give a proper structured answer. Okay, now let's ask another one. We have in this paper we have steganography as well. So tell me about steganography. Okay, sorry about the spelling. Steganography. Okay, again based on the provided context, steganography is an art of hiding one type of data into another type of data. Okay, here again you see sufficient relevant information found in the knowledge base. Okay, now in this particular vector database, I have only uploaded this one PDF. Okay, this PDF. So let's just ask some uncommon question to it, and let's see how it will answer me that. Okay, so let's say what is the cure of cancer? Okay, something out of the line. Unfortunately, according to the provided information, there is no definitive cure of cancer while treatments can be effective. Now, you see, we haven't provided any information, but we still need to have some answer, no? So now it is still able to give me some proper structure answer. Okay, now if I see the trace of it, you will see that first, of course, our router node. Then in our rag lookup, it's saying that rag lookup perform content not sufficient, diverting to web search. Okay, so our judge node is telling you, okay, the question user is asking, we don't have the relevant information in our knowledge base, so we have to go to our web to get the get the relevant information. Okay, then it is performing, then it is forwarding that particular agent to our web search node. Then again web search perform result retrieve proceeding to answer. Okay, then in our answer node we are calling our LLM with all this context to give us a proper gathered knowledge. Okay, so this is what this agent will do, and you can call it this, and you can call this an hybrid AI agent because we are using our private knowledge base with our web based knowledge. Okay, and we also have performed some intelligent routing based on our judge LLM. Okay, like judge LLM node which will act as a judge, which will give us the verdict of sufficient or not sufficient retrieval information. Okay, so this is what we are going to build in this video, and so now let us understand some of its concept and some of its framework. Okay, so now let us understand and see some of its concept, is its architecture, its core module, and then we'll go to the code. Okay, so the first concept that we'll revise a bit, which is our rag framework, like how rag works. All right, so here you could see that from this left side in this red dotted box, here we'll upload our documents, and then the next step in our rag performs that we need to chunk those our documents into multiple chunks. Then we need to pass them through an embedding model, and in this case we are using HuggingFace sentence transformers model. Okay, then we'll convert those chunks document into a vectored embedding into 384 dimensions of vector. All right, and then we'll upload them to our vector database. Now we are using Pinecone Vector database in this application. Okay, now if you see from the right side, let's say users perspective, let's say users parse a query or a message. Now we again need to embed that message into a vector embedding. Okay, and then we'll pass that to our vector database to retrieve some relevant information as per that particular embedded message. Okay, and then that embedded message that retrieved relevant information from our vector database and our given system prompt will pass all of them as a context to our LLM. Now you can use GPT, Groq, Gemini, Anthropic, Claude, whatever you want. Okay, then LLM will help you to give a proper structure output, which will be an answer which will be providing to our user. Okay, this is just the overview of how rag works. All right, now after rag, and this is our agent's diagram, like how our agent will work. We have this start node, then we have this router node. From this router node we'll be having four way where we can go. One is this end, which is for our direct greeting, this answer node for to give any structured output, and then this rag lookup where if the answer for this query we can generate from our knowledge base, then we'll go to this rag lookup, and in this rag lookup we have our rag judge. If that judge thinks that the retrieve information is not enough to give answer for that query, we will go to this web search node. Okay, so we'll have our query then we'll have our user query, our system prompt, then some information we gather from our web or our knowledge base. We'll pass them as a context to our this answer node, and this answer node will give you that final structure out. Now if I see, now one more thing that I wanted to tell you guys, that all those LangGraph important elements. Okay, so I have created one video before that what this LangGraph's important elements, but still let me just give you a brief of that. So these elements, the most elements, so the first element would be our state, so LangGraph state. And what is this? This is a memory or context that carried throughout the graph and which can be updated at each node. Okay. Then we have our LangGraph node, which is the function or step that does something with the current state and returns on an updated state. Alright, then we have graph, which is the entire chain of our logical collection of nodes with connected edges. And edges is, this is the edges, and these are the connection between our nodes, and they determine the flow of execution. Okay, and our state graph, which will act as a blueprint, which is the object where you define our state, our nodes, and how they are connected. And here we'll define the whole graph blueprint. Now there are a couple of more elements as well. We have tools, which are the gadgets, which are the external APIs like we are using Tavily or our RAG-based tools, those things. And these are the tool nodes, a special node that will help you to invoke a tool based on your current state. Okay. Then we have this start end element, which start means the entry point of our graph, end means where our processing stops. Runnable is the final graph object that will call to start the whole our agent's workflow, which is that play button. Okay. Now I'll be giving you all these diagrams in my GitHub repo. So if you want, you can take the reference from there. Okay. Okay. Now there is one more thing. This is our agent's workflow, which I've showed you before as well. And this one is been generated by LangGraph, and this one just to give you some more in detail explanation. Okay, for each and every node I have given you the whole description of what this node will do. Like for this first node, you could see this router node. If you see in this here, for this router node, I have defined the purpose of this node, the inputs that will take, its core logic, its outputs, its next possible node, so that if you tends to create this by yourself, it will be easy for you to build this if you know the basic coding. Okay, and we'll code our backend with the help of this diagram as well. Okay, so that's saying. And one more thing that I would like to show you, our agent's workflow as like our application's workflow. Okay, so user will give its query, then we'll be passing that through our API request. Then we'll have our agent's code logic, then our data, then our agent interacts with external data sources like our Tavily API. Then we'll have our final response. Okay, so this is the one shot overview of the agent's workflow. All right, and again we have this PDF where I have written down all the important high level application architecture, like all those conceptual layers. Okay, so we have our UI layer, API layer, then code logic or our main agentic layer, then our knowledge base layer, then external service layer. Then here we have our overall application flow. So if you want to create a proper report, so it will help you for that. Then our core modules and their features, like our front end, we have app.py, UI component.py, backend API, session manager, configs. So I kind of try to make it as modular I can. Then in backend we only have 3 files: main, which is the entry point for our FastAPI backend, then agent.py, where we'll define and where we structure our whole agent, and vector.py, where we'll manage the interaction with the Pinecone Vector database. Okay, and of course config.py, some utilities as our requirement.txt, .env file. That's it. And we have another one, and this is our technology stack and what tech we are using. So we are using Python, of course, and Streamlit for our front end, and FastAPI, LangGraph LLM ingestion in our backend. Then our basic frameworks, we are using FastAPI, LangChain, LangGraph, Pydantic for our proper data validation. Then Python.env, Python multipart. Then our front end framework, Streamlit. LLM, we are using Groq LLaMA 3. You can use whatever you want. The vector database, Pinecone, embedding model, HuggingFace embedding, sentence transformer, all MiniLM L6 V2. Okay, so whatever information you need, I have given you everything in this particular GitHub repo. throughout this video, if you ever feel stuck, you can always take the reference from here. Okay, so now let's start with the coding part. Okay, so before we begin with our coding, we should know what are the APIs is our requirements, right? So we need our Pinecone API key, and we'll be needing our Groq API key for sure, and to manage our Python package, we'll be using UV. Okay, all right. So now we shall create the project setup first, and then we'll install our required on dependencies. Okay, so again UV init, UV v and v, and the reason I'm using UV, when you are using LangChain, LangGraph, so you need to install a lots of dependencies, right? So UV being the fastest or pretty useful Python project manager, it's become easy for you to handle and install your dependencies, and also control your dependency manager, because this pyproject.tml file, so it kind of helps you to understand what are the dependencies we have, like, and also for the deployment purpose. Okay, so .v and v, then to activate this I'll use this command .v /script /activate. all right, so here first I need to have my requirement.txt file, requirements.txt. okay, and I'll paste my dependencies over here. So here we have LangGraph, like all those LangChain communities dependencies. LangGraph for sure, LangChain text splitter, sentence transformer, as we'll be using embedding model from HuggingFace. So for that, also for LangChain HuggingFace. Then PyPDF, docx to txt, unstructured, FastAPI, unicorn to have our backend setup. Then python.env to manage our environment variables. Pinecone, of course, for our Pinecone database, and of course for Groq, LangChain Groq, and our web search we'll be using our Tavily. Alright, so I'll save this, and to install these dependencies, UV pip install -r requirements.txt. okay, alright, so we are done with our installation. Right now that we have installed our all dependencies, so let us check with a simple backend API. okay, and also it will help us to check that all our installed dependencies are working. okay, so I'll simply create a test API endpoint. So I'll import fast sorry, it will be from FastAPI. So from FastAPI I'll import FastAPI. Then I need to initialize the FastAPI server. So FastAPI with the name, let's say LangGraph AI agent. Alright, then a simple get API endpoint. So app.get health, and then async function with the name of health check, because we'll be checking the backend server. So then I'll return a simple status with OK in it. Okay, I'll save it, and then I'll come over here. I'll run the application as uvcorn main file app with -- reload, so that whatever changes will be making after that, it should reload automatically. Okay, so let us wait. Alright, it's saying uvcorn for help. Alright, so main.py FastAPI app.get /health return this uvcorn main app All right, the spelling is wrong. So load. Okay. Right, you could see our UVCon is running on port 8000. So I'll come to my Postman for the testing. And here in my Postman dashboard, first I'll create a blank collection. I'll name it as agent bot. All right. Then I'll add a new request, and it will be a GET request. So I don't need to change anything. Then with this endpoint of /help, I'll send the request, and you see a status OK. Right. So all our installed dependencies will be working. So now we shall create our backend server. Okay. So now for our backend application. So let me first clear this terminal. All right. So I'll create a directory as, let's say, backend. Okay. All right. And inside of this backend, and first before all of that, let me create the .env where I'll store those API keys. So .env. So I need Pinecone API key. Then I'll be needing Pinecone environment, which is of course US East 1 for the free tier of Pinecone. Okay. Then the name for our Pinecone index. So Pinecone index. Sorry. Pinecone index name. And what do we need? We need our Groq API key. Groq API key. And we need Tavily API key. Tavily API key. Alright. And we need our doc source directory where we'll store our uploaded documents. Okay. So alright, and another one we need is our embed model. Okay. So these are the okay. Actually, we don't need this. Yeah, okay. Embed model. Alright. So now, and for this embed model, we'll be using this sentence transformer. So let me just write it over here. So sentence transformer / call MiniLM L6 v2. Okay, so we'll be using this embedding model from HuggingFace. All right, and in our doc source directory, our directory name would be data, and then we'll be having our API keys, and for our index name we'll be using rag index, and for the environment we'll use US East -1. All right, and for your Pinecone API key, Groq API key, Tavily API key, you have to add your own API keys over there. Okay. All right, now under this backend, first thing I need to do, I need to grab these API keys or all these environment variables from this .env to my backend folder or to my backend application. So for that, I'll create a file as config.py. Okay, and here I'll import OS, then import OS, then from .env I'll import load.env. okay, fast, simple, load your .env function. All right, then I simply need to get all my variables from my .env file. So vector databases, so sorry, Pinecone API key os.getEnv with Pinecone API key. Okay, so like that we need to get all our environment variables. Okay, so here we go. So these are the rest of them. So Pinecone environment, Pinecone index, Groq API key, Tavily API key, embed model, and doc source directory. And I'm also using this default name because let's say you were trying to deploy this application and by mistake you forgot to add those env files, so then by default it would create those rag index. It would understand that which environment you want to use and it will use this default transformers. So it's a kind of a best practice to use a default value for your environment variables, of course not for your API keys. Okay, so now we'll create our vector store module. Okay, so I'll first create the file. So vector store.py. Okay, all right, so here so first let me define it. So first let me import those libraries. Okay, so import os, then I need to import from Pinecone I need to import Pinecone and serverless page, as we are using the free tier of Pinecone vector store, so we need to use a serverless vector store. Okay, then as we are using Pinecone vector store, so LangChain, so from LangChain Pinecone I have to import this one, Pinecone vector store. Okay, then again LangChain HuggingFace, I'll import which one? I need to import HuggingFace embeddings. Yes, because we are using the HuggingFace, like we are using the embedding model from our HuggingFace, right? Then for our text splitter from LangChain, this where is gone? LangChain text splitters, I'll simply import a recursive character splitter. Okay, all right, and to get our Pinecone API key, I'll just call my module. So from config I'll get my Pinecone API key. Okay, and then I'll simply set the environment variables for Pinecone, right? So here os dot environment, I'll take my Pinecone Pinecone API key. Okay, Pinecone API key. All right, then I need to initialize my Pinecone client. So to initialize that, I'll take a variable as PC. Here I'll call my Pinecone and I'll simply pass the API key, which is Pinecone API key. Okay, then again I need to initialize, not initialize, I need to define the embedding. So define embedding models. Here I'll take a variable as embedding. I'll call HuggingFace embeddings, and here I'll simply pass the model name, and the model name is this one. So I'll copy this, then under quotation, under quotation I'll paste that. Okay, now we need to define our two function, right? So first function name, the first function will be our retriever. So retriever, right? So retriever function. Okay, just wait. Right, so here let's say def simple get retriever pass. Okay, then we need to create another function, and this will be for upload documents to vector store. All right, so define it. So add document pass. Okay, now we gotta define those functions. Okay, all right, so in my get retriever, let me first define what this function will do, right? So under three quotation I'll define key it initializes and it returns what? It returns the Pinecone Vector Store retriever. So retriever. Okay, all right, so after that I need to ensure the index exists, and otherwise create if not. Okay, so what this means, like before initialize our vector store, I need to create an index. Right now this index can't be same in my vector store. Okay, so let's say I'll be naming my index name as rag index. Okay, so I need to make sure that this already doesn't exist in my Pinecone vector store. So for that, if index name not in pc dot this list of indexes. Okay, so list of indexes, then I'll take the names. So names. Okay, so if it doesn't exist, then I'll, let's say, write this thing, the creating new index. Okay, so if and only my this particular index name doesn't exist, then I'll create the index, and to create it I'll use create index. Okay, and then I'll provide the name. So name would be of course simple index name, and for the dimension would be 384. So 384, and the metric would be, you can use dot product, but I'm using cosine. Okay, you can use whatever. So cosine. Then for SPC I'll use serverless spec, and here I need to provide the which cloud I'm using. So cloud would be AWS, and region would be simple US East. It will be US East 1. Okay, so this is how I'll create my Pinecone index. Okay, then a simple statement that created Pinecone index. All right, okay, now I need to get my Pinecone vector store, right? So in my vector store variable, vector store, here I'll simply call Pinecone vector store, where I'll pass the index name. So index name, this one, which is this one, index name. Okay, and with also the embedding, will be embedding. Okay, let's change the name of it. So I want to make it embedding, so I need to change this from embedding to embeddings. Okay, all right, so this will create the vector store, then I'll simply return it. So vector store dot as a retriever. Okay, retriever function, that's it. All right, so this will help me to create and return my vector store retriever. Okay, so now for this upload document function, so this function will receive a text content in form of a string. So text content with string format. Okay, so I'll cut this pass and I'll add a simple doc string to define that what this function will do. So this function will add a single text document to the Pinecone vector store and split the text into chunks before embedding and upsorting. Okay, so now to check some safety check, we should do that if there is, so if not text content, like if by any chance there is no any uploaded document, then what it should do, right? So for that, simply raise a value error where we'll pass document content, document content cannot be empty. Okay, all right. Now first thing we need to do that after uploading whatever document, the first step would be to split the document, right? So our text splitter, here I'll call the function of recursive character text splitter. Okay, then here I need to provide some parameter. As first is in how many chunk I want to divide, right? So chunk size I need to give 1000, and you can modify it as per your requirement. Okay, chunk overlap I'm giving it 200, and add start index I'm making it true. Okay, chunk overlap 200. Okay, this one. All right, so after that I need to create a simple object where I'll store these documents, right? So give me a comment. So create LangChain document objects from the raw text. Okay, so I need to store the raw text somewhere. So for that, let's say documents, here I'll be calling my text splitter, then create a document. So create documents where I'll simply pass my text content. So here is my text content. Okay, so right now I have stored those raw text like within this documents variable. Right now for some message, let's say split, it will be splitting document into chunk for indexing. Okay, just to give some message keywords happening under the hood. Okay, all right, so after that we need to get our vector store. So get the vector store instance to add documents. All right, now to get the vector store, we'll use our vector store. So vector store, I'll pass my vector store over here. So Pinecone vector store, where I'll simply pass the index name, which is index name, and I'll pass the embedding, which is embeddings. Okay, so I'm calling this particular vector store. Okay, then the last step, add documents to our vector store. Right now, to do that, simple our vector store dot add documents, and I'll simply pass the documents. Okay, and again for some message, successfully added chunks to Pinecone vector store. Okay, all right. Now after that, we're going to define the main module where we'll define our agent and our agentic route, our agent decision making process, everything. Okay, so now that we have done with our vector store.py file, now we need to build our main agent's brain with in our agent.py file. Okay, so I'll just create a new file, and here I'll define my whole agent. Okay, so agent.py. So the thing I have mentioned in my previous video, that whenever you have to create a agent with LangGraph, um, the first thing that you need to define is our state of the graph, or the state of our whole application. Okay, and what is a state? And a state is a shared data structure which will be used throughout our application. Okay, so we'll first define that, and for that I need to, let's say, import dependencies, right? Dependencies. Okay, now I need to import from typing. I need to import type dict, of course, type dict. I need to import list and literals. Okay, literal. All right, now from LangChain core, here I need to import these messages, where I need to import this base message. And why this base message? If you see what it says, and you'd see that base message are the inputs and outputs of the chat model. Like the input our user will give, I'll store in my base message, like using this base message. Okay, now I'll define the state. What is state? State is a shared data structure. Right, now to define that class, I'll name my state as agent state, where I'll pass this type dict, and I keep the total value as false. Okay, then I need to mention that which kind of information that I'll be storing in my agent state. So number one is, of course, our messages, which will be in the form of list, and which would be our base message. Okay, then our route. Okay, route, and we'll be having four kind of route. So one is rag, another would be, let's say, web, and we'll be having this answer route, and the last one would be end. Okay, and then I need to have the output from our rag node, so rag string, then the output from our web node, like after the information we'll be having after the web search. Okay, and then I also need to have the information about that web search enable tool. Okay, web search enable, and here I'll use bool. All right, so this is my agent state. Okay, now I'll save it. Now after that, what I've mentioned in my previous video also, that after defining the state, we need to start building our node. Okay, so here we'll build our node. Okay, so for individual functions, we'll be creating our node. But before node, let us first see this diagram. Okay, so this is the diagram that, and this says how our agents would, like how our agent would work. All right, so the first node that will counter is this router node, right? And how this router node has been made, there is some description about that. So the purpose of this router node is that agent initial decision maker. It analyzes the user's query to determine the most appropriate next step, like the RAG, web, answer, or end. Okay. Then inputs, messages, web search node, and these are the code logic. But the concept here is that to build this node, we need to have couple of predefined element like this router LLM that will help us to kind of like that will help us to give the structure output about the route decisions. Okay, so before we define our node, we need to build some predefined component. So let us do that first. Okay, so the predefined components are these parentic schemas. Okay, so let me write it down first. So parentic schemas for structure output. Now why we need this? Because see, every LLM's response is a bit of different. Okay, and is a bit of free flowing responses. So whenever your whole application is depending on the answers of LLM, you better accept those LLM in a particular manner, and that's why we'll be accepting those LLM's response in a set of structure output. Okay, and that's why we'll build these classes which will inherit those pydantic schemas. So I'll first define two class. As the first one would be my route decisions. Okay, route decision which will inherit the base model. Okay, I haven't imported that base model, so here I'll import from pydantic. I need to import that base model. Where is the base model? Here, base model. And I also need to import field. Okay, all right. Now this classes will inherit this base model. So base model. Okay, now I need to structure the output for this route decision. So first is route. So route decision mean this node. So this particular schema will tell me that in which route my route node is telling me to go. Okay, so like simple, I'll be using literal because it have to be one of these four route: this RAG, this web, this answer route, and this, sorry, this end. Okay, so any of this one route would be where we have to go next. Now, as I've said earlier in the demo or in the intro part, that whenever user will ask some normal greeting type query like hello, hi, so I don't want my application to go through all the process, right? So for that we have this another data type option, which is this reply, where I'll be having this string or none. It could be a string or it could be a blank. Now I need to define its field. So field, it would be a none, and I need to define a description of this field. So the wrong spelling, FILD field. Oh, sorry, FIELD. All right, field none. Now in this description part, I need to provide that field only when route would be this end. Okay, so when my route is saying end, then I don't want my application to go through those RAG lookup node, answer node, and to use LLM or web search to get the information. Because if someone is saying hi, it's the direct response, hi, how are you, like this kind of response. So that's why I'll be having this reply. Okay, now another one is our RAG judge, which will judge the opinion of which will judge the opinion that the question user is asking, can we generate the answer for that from our knowledge base or not. So this RAG judge will help us with the proper information that yes or no. If it's no, then we have to go to web, otherwise it's enough, it's it's good enough to give the answer from our knowledge base. Okay, so rag judge base model, and we'll use this simple sufficient variable. Sorry, the spelling sufficient, this one is right? Sufficient. It will be a simple bool. It will be either yes or no, like sufficient yes or no. Okay, now I need to define the field. So field where it will be a object. Now pass the description. Oh, I did 4 1. It will be on 3 description. Now here it would be simple that true if retrieved information. So true if the retrieved information is sufficient. So sufficient to answer the user's question. Okay, and false otherwise. That's it. Okay, so that's done my rag judge parentic schema. Okay, now these are the parentic schema in which like these are the format in which I'll be taking the response from the LLM. Now I need to align my LLM response with the schemas, right? So for that I need to define my LLM instances. So LLM instances with, let's say, structured schemas. Okay, so of course first I need to get my Groq API key. Okay, I didn't import OS, so let me import OS. Okay, so OS dot environ. Now here Groq API key. Okay, I also didn't import Groq API key. So from config I need to import Groq. Let's import everything. Okay, Tavily as well as Pinecone. Okay, all right, now in this here I'll set it to Groq API key. Okay, now I have Groq API key in this environment. Okay, right, now I'll be having 3 instances, one for our this route decision, one for our this rag judge, and one a normal instance which will help us to give the answer. Okay, so let us create one. It's router LLM. Come on, first one will be this router LLM. So router LLM. Okay, here I will use chat Groq. Okay, so from LangChain Groq I need to import chat Groq. Okay, now here I'll call the chat Groq, and then I need to pass that which model I'm using, and I'm using that llama 3 model. Okay, so llama 3 70b with 8192. All right, and there's another important parameter which is this temperature, which kind of controls the like how variable or how creative the response will be. As for router LLM I might need some good creativity, so I'll use this. No, actually for router LLM I don't need any creativity, right? I'll use simple 0. Like when I'll be using that LLM instance which I'll use to get my answer from the query, there I need to use some good temperature number. All right, so this is the router LLM instance, but I need to align this with my Pydantic schema. So for that we have this feature in LangChain, which is this with structure output, and here I'll simply pass my schema, which is this route decision. Okay, now I'll copy this one, I'll paste it, and I'll change the name as judge. So JUDG rest would be same. I need to change this in rag judge. Okay, then I'll paste it again over here, and I don't need this. I'll make it 0.7, and this will be my answer LLM. Okay, so this instance I'll use to get my answer, not in caps. Okay, all right. So now for our first node, right? So let us first see the diagram. So this is the our AI agent's workflow. Okay, so the first node that we'll encounter is this router, right? So what it says, that's code logic of this router node, is that it first extracts the latest user query, right? So and then we'll call our router LLM to get an initial route decision, then a conditional override where we'll override the condition of web search enable. Then this is our outputs. In our output we'll have our route, our message, and our web search enable information. Okay, all right, now let's do that. Okay, so first let us recreate that. So I'll use this node 1, which is my router decision node. Okay, so simple def router node. Right here we'll pass my agent state. What is agent state? And my every node will return, every node will return the updated agent state, like the updated state. So agent state. Okay, so the first thing is, let's print every step. Okay, so the first thing is, see, entering router node, right? So here extract query, right? Now how I'll do that, let's say define a variable as query. Okay, now see, the thing, like whenever user will give a query, it will store in this message list in this agent state, right? So I need to extract the message from this agent state messages list. Okay, now there is another thing. I have stored those messages as a base message. Now these base messages can be AI message, human message, and system message. But what do I want? I want that human message. So I need the instance of that human message, right? So for that, let's say if is instance of, sorry, don't be like that. So let me do it here. Okay, first. So let's say if is instance of the message, and I'm taking message in short as M. If that instance is the instance of this human message, I haven't imported human message, so here I need to import human message and also AI message as well. Okay, now here this will be a human message, so human message. Okay, if the instance is the form of human message, what do I want? I have to extract the content, right? So if it is human message, then for message in my state message, sorry again, for m in that particular state of message, right? But the thing is, I need to extract the latest message. Okay, but in list my latest message will be stored in the bottom, so I need to reverse it, right? So I'll use this reverse function here. I'll use reverse. So for m in this reverse message, I need to extract the content. So m dot content. All right. Okay. Now, sorry, content. Okay. And else a blank string. So this is the logic of extracting the message which is the part of a human message. Okay, but there's another thing, human message will be a lot of type, so I need to get the next human message, like the latest human message, right? So for that I need to use this next keyword, under which I need to wrap up my m.content. Okay, wrap up my this content. Okay, now I need to store this whole information under my query, right? So to make it much more easily readable, I'll use this next keyword over here, and I'll simply store my, I'll use this if instance here. Okay, then this one for m beside that, and this m content at first. Okay, so m dot content for m in reversed state message if is instance is human message, otherwise, right, otherwise I need to use this blank. Okay, now done. So this is how this logic will work, and I'll just comment it out saying there is an error. Okay, so state message, yeah, state message will consist in this, right? And state message here, if instance here, I don't need this one then. All right, so I need to have a bracket over here first. So, all right, so this stores under the if instance message, and if my if condition fails, I'll be returning a blank string. All right, so I hope you understand the logic how we'll extract the latest human message. Okay, and to make you understand, I've written this logic in this if-else ladder. Okay, all right, now we have extracted our query. Now we need to get the information that if the user have enabled the web search or not. So in a variable web search enabled, I'll simply take the state dot get the value from that web search enabled. Okay, web search enabled, so state dot get this one, web search enabled. I'll store, copy this one, I'll paste it in here. Okay, and by default I'll make it true. Okay, all right, now here I'll be having the information about have user have enabled it or not. Let me print this as well. So router received, sorry, router received enabled. Okay, all right, now we have extracted the query, we have got the information that has user enabled the query or not. Now we need the system prompt. Now it's a big system prompt, so here, all right, so here you can see, and here we have structured our system prompt. So first we have, so the first system prompt is this one: you are an intelligent routing agent designed to direct user queries to the most appropriate tool. Your primary goal is to provide accurate and relevant information, all those things. Okay, now, so this system prompt is for this simple guidance, that what kind of node you are and how you have to perform. Now thing is, we have a condition over here that web search enabled. So if the web search is enabled, then we have to add another system prompt with this system prompt. So here you can see we have added this system prompt plus, so we are adding this system prompt as well. So here, if the web search enable is true, you can use web search for queries that require very current, real-time or broad general knowledge. and some particular precise prompt for that. Okay, and here is the thing that if it is RAG for queries about specific entities, historical facts, product details, web for queries about current events, live data, very recent time. So you have to properly cater the web enabled prompt. Else, if this web search enable is false, then we'll be adding this prompt. Web search is currently disabled. You must not choose the web route. If a query would normally require web search, you should attempt to answer it using RAG or directly from your general knowledge. Done. Now, after that, we have to add another system prompt. Here it is. Like, see, to cater our route, RAG and web, we have some precise prompt. Now we have two more route, answer and end. So for that we have this one. For answer route, for very simple and direct question, you can answer without any external lookup. End for pure greetings or small talk where no factual answer is expected. Okay, now here is some example. User, what are the treatment of diabetes? Route would be RAG. What is the capital of France? And the route would be RAG. Common knowledge can be in the knowledge base or answer directly if LLM knows. Now there are some example, and it's always better to kind of add somehow like as many knowledge you can to provide as a system prompt so that your LLM understand exactly how to operate. Okay, so this on the system prompt part. Now we have to add this message and our query in our messages list. So I'll get a list, and here I'll add my system prompt. So system prompt, which is this system prompt, and I need to add the query. So here I'll use the users given query. Okay, done. I'll use this message in my to get the information. Okay, now we have our system prompt, we have our query, everything. Now we simply need to invoke our route LLM. Okay, so we have our route LLM. I'll use this invoke. I'll invoke simple the messages. So messages. Okay, and now here again we are storing the information in the format of this pydantic schema, right? So I'll store them in this route decision. Okay, and this is my result. Okay, all right, now I have the information of like the information from LLM in this result. Okay, now I need to have another information that what is the initial router decision. Cause see, in the demo you have seen that we are printing the trace. So to actually have the trace, I need to have each and every information of the agent. Okay, so let's say another initial router decision, and I'll take that from that result dot route. Why I'm using this route? Here you could see in this pydantic schema I'm using route where I'll be storing this literal. Okay, so that's why result dot route. Okay, all right, and now here is the thing. Okay, that is done. Now I have to add another logic, which is override decision to go for webs. Now here is another thing. Okay, that let's say user haven't enabled that web search option, but the kind of query you are asking that need a web search. So LLM as a general LLM will go for the web search, but I want my application to work as per the user's query, as per the user's information. So if users don't want to go to web search, why would I? Why would my application will? So that's why I have to override. The spelling is wrong. So I have to override that LLM general decision. Okay. So for that I'll use if not web search enabled. Like if web search is not enabled, right? not enabled, and this result dot route it's saying key result dot route is saying key web. If my application is saying, hey, I need to go to web, by users haven't given the permission, and like if my application wants to go to web, but the user haven't given the permission, so I can't. So that's why I have to override it. So if web search is not enabled and result.route is web, then result.route I need to override this with this rag. Okay, and also as I've said, we need to print the trace. So we need to have the router override reason, like why our router has overridden, right? So here we'll add this simple web search disabled by user redirected to rag. Okay, now to actually add this kind of thing, we have to first initialize this. So route override reason, I'll initialize it as none. Okay, so if this all right, let us print what our router is doing. So router decision overridden change from web to rag, right? All right, done. Now I'll get outside of this if statement, and I'll simply print another statement. Sorry, it will be print another statement as router final decision. Router final decision is what? This result dot route, and what is this reply? Okay, the reply I'll use this if it is end, then I'll use this result dot reply. Okay, so this one for this edge case of if our user is asking, hey, how are you, this kind of silly questions. Okay, so that's been done. Now I simply need to return my all those information. Okay, so I'll initialize a new dictionary, so out, and here I'll store all the information. So messages, here I'll keep my state messages, then I have to get the information of route, which is I'll get that from result.route, right? So result.route, then I need this web search enabled option, which is in this web search enabled. Okay, all right. Now for the tracing part, I need to make sure that my enable that web search enable has been overridden. Okay, so if router override reason is happened, then I need to make sure that in out this initial router decision would be this initial decision. Okay, and for my router override reason, I'll copy this from here, I'll paste it here. Okay, router override reason will be my router override reason. Okay, initial router decision. All right. Router override decision. Okay. All right. Now there is another edge case that if my route is going for the end, so we have take care for our rag, for our wave, for our answer. Now the last edge case is for our end. So if that result dot route is saying for end, then what we'll do in for this out message, I'll use the state and messages, and here I'll add my AI message, my AI message, where I'll simply pass the content in the the content inside the result as result dot reply, or for default is hello. Okay, right, this done. Now the last thing we need to do is simple. This node walk is done, so existing router node. Okay, and will return the out. Right, so this is how this this router node will work. Okay, and you can easily check with this description our next possible. So we have take care all edge cases, like all cases, not edge cases, all cases for this rag lookup, web search, answer node. We have defined all these outputs, all this code logic. Okay, so if you see in the diagram, after router our next node is this rag lookup. Okay, where we'll extract information from our vector database. Okay, so now for our second node, right? So let me write it as second node, node 2, where we'll use this rag lookup. Okay, now what this node will do, let us see through our diagram. So here in this rag lookup, so if I come over here, you see for this rag lookup node, the purpose of this node is to retrieve relevant information from the internal knowledge base, our Pinecone, and judges its sufficiency to answer the query. Okay, so these are the inputs, the code logic, the output updates, the next possible nodes, so that you understand what this node works. Okay, so let's do that, right? So first I'll print what this node will let. Okay, first I need to define it. So def, I'll use rag node, and again a node will take the state. So state, our state name is agent state, and it will return the updated agent state. So agent state. Okay, now I'll print that's entering rag node. Okay, all right, now as per our previous node, the first thing we did to extract the query, and we'll do the same in this case. Okay, but first let me minimize this node. All right, so I'll use this again. So in this line I am just extracting the last human message. Okay, and again I need to do one more thing. I need to get this web search enable flag. Okay, so I'll just copy these two lines. Now I'll minimize them and I'll paste it below them. Okay, so wrong indentation. Okay, so web search enabled, so state.get web search enabled true, then print that router received web search info. I need to print another information about print rag query, which is this query. Okay, all right, now I got the query, I got the information that if the web search is enabled or not. Now I need to get my chunk. Okay, so for that, in the chunks variable, I'll I'll provide the query to get the relevant chunk. Okay, so for that I'll use the tool feature of LangGraph. Okay, so for that first I need to import tool. So let's say here under this I'll import from LangChain core dot tools. I need to import tool. Okay, and so I'll come, so I need to define the tools, right? So here I'll give a comment as tools. Okay, so to build a tool we'll have to use this @tool keyword. So tool, then we need to define our tools. So def rag search tool. Okay, now what this tool will take, it will take that particular query in a format of string and it will return the string. Okay, now how we'll do that? Again, for a simple doc string I'll use that top k chunks from knowledge base. Okay, and empty string if none. Okay, now I'll simply use a try catch, try except block. So except exception as e. I'll simply return an error as rag error e. Okay, so that's my exception. Now in this try block I need to get my retriever. So let's say retriever instance. Okay, now here I'll call the retriever that I have built in this vector store.py. So in this vector store.py we have built this this retriever function as name of get retriever. Okay, so I need to import that. So here I'll import from vector store import that get retriever, right? Here I'll call that function get retriever. Okay, now I need to get the docs. So in docs I'll use retriever instance dot invoke, and here I'll pass the query and the relevant chunk I'm taking at 3. Okay, you can take it 5 as per your thing. Okay, now after docs I need to return. So in this particular format I'll join this with, let's say, for docs like d in docs I need to extract d dot page content. Okay, so this should finish within this join page content. Okay, and then if docs else I want a simple empty string. Okay, so this is what will return, and this will act as our rag search tool. And after that I'll simply call that tool over here. So here I'll call that particular rag search tool. So rag search tool dot, here I'll use invoke and I'll simply pass my query. Okay, so here I'll get the relevant chunk from my knowledge base as per the given query. Okay, now logic to handle chunk. Now let's say we got the chunk. Let's say we have two kind of scenario, that we might not get the chunk or we may got the chunk. Okay, now after getting the chunk there is two kind of scenario that might arise, that there could be some problem, some error might happen, right? So for that, if my chunks dot starts with, I'll use that starts with, what happens if chunks start with this error. Okay, then what I'll do, simply use if chunks starts with the simple rag error. In this one, in this tool, you could see for the exception we have this statement will start with this rag error. Okay, so if we get this rag error, then simply print something as, let's say, rag error, that particular chunks. And now checking web search enable status. Okay, mean if we fail to retrieve information from our knowledge base, then to give you some answer we have to go to the web. Okay, now if rag fails and web search is enabled, so if rag fails and web search is enabled, then in our next route I'll make it web. Okay, if web search enabled, otherwise I'll pass it to the answer node. Okay, and then I'll simply return that particular updated state, and the rag would be the blank as we haven't gotten any answer, and the next route is this next route. Okay, so this is what will return if we fail to generate some chunk from our knowledge base. Now let's say we generate some knowledge from our chunk. So if there is some chunk, I'll simply print that retrieved retrieved chunks. Okay, and here I'll take the chunks first 500. Okay, and else no rag chunks retrieved. All right, so now we have extracted the query, we get our information about the web search. Now we handle the logic with our chunk. Now comes how this node will react. Like if it has to give me information from web, from rag, I need to give it some, like, as this node is a judge node, and it will judge that the information I'll be having from my rag, is it sufficient or not. So I need to have some system message for that. Okay, so this is our judge message, under which I have this system prompt. You could see you are a judge evaluating if the retrieved information is sufficient and relevant to fully and accurately answer the user's question. Okay, reason only with a JSON object, sufficient. Example question: what is the capital of France? Retrieve Paris is the capital of France. True. Okay, so you have to cater your judge node properly. Then we are taking this user question query, then retrieve the information chunk. Is this sufficient to answer the question? Okay, now after this system prompt information, I need to get the verdict from my judge, right? So the verdict here, I'll call my rag judge, and where I'll pass this judge LLM dot invoke this judge message. Okay, now I got my verdict. Let's print something. Let's say rag judge verdict. Okay, dot, I'll use sufficient. Okay, now as this work is done, so I'll simply write that existing rag node. Okay, my work is done for this rag node. Now to return, okay, now I need to return those route. So here I need to decide the logic for, let's say, decide my next route based on sufficiency and web search info. Right, now here's the thing, if verdict dot sufficient, then my next route would be answer. Okay, but if else, my next route have to be the web search. But there comes another information key, is that web search is enabled or not, right? So that's why if that verdict is not sufficient, then I'll go to web if web search enabled, else I'll make it to the answer directly. Okay, and for a simple statement I'll use key rag not sufficient. Okay, and web search enabled. So here I'll pass my web search. It's going to be an if string for that. So web search enabled. All right, and that's why my next route is going to be this next route. Okay, so this is how we'll handle that web search enable. Now what we'll return? We'll return this simple our state, and we have to return our next rag route, which is like the output for our rag, then output for our route, which is next route, and we have our next route logic. So then you also need to update that web search enabled, which will be web search enabled. Okay, here I need to give a comma, done. Okay, so this is how we'll cater our rag judge. Okay, we are done with our rag lookup node. Right now, if we came back, you could see our next node is this web search node. So here the purpose of this web search node is to perform the real-time web search to gather external up-to-date information, respect the user's web search enable setting. Okay, and also we have our input, code logic, output, next possible, all those things. Okay, all right, now let's do that. So first here I'll give a comment as node 3, which is our web search. Okay, all right, now first let's define our function. So def web node, which will take our agent state, and which will return as well as our agent state. So agent state. Okay, so again print what this, like we are entering in this node. Okay, so entering web node. Okay, Then I'll come here. The first thing I need to do that I again need to have this extracted query. Okay, so I'll copy these two lines. I'll paste that over here. So I have my query, like I have my extracted query and my information about the web search. Okay, now after that, if not web search enabled, like if user hasn't enabled web search, then what we'll do, web search node entered but search is disabled, right? All right, so after that we'll return that updated state, so that particular updated state, and we'll return our information of web, which will be this information that web search is disabled. So web search was disabled by user. Okay, all right, then we also need to provide the information of route, and this route is answer. Like if the web search is not enabled, then our next route will be what? That answer node. Simple. Now I'll print a simple statement as web search query, which is this query. Okay, now here snippets, and here I need to invoke with my web search tool. Okay, so for that I'll come over here, and for the first I need to get my Tavily API key. Okay, so here os dot environ, here I'll bring my Tavily API key, and sorry, I'll use Tavily, not inside that, outside of it. Tavily API key. Okay, then I'll create a Tavily instance of Tavily where I'll simply call this Tavily search. Okay, so we haven't imported that, so for that I need to import Tavily search. So from LangChain Tavily, so LangChain Tavily, I'll import Tavily search. Okay, Tavily search. Now here I'll call this Tavily search where I'll pass the max result, this max results, which would be, let's say, 3, and the topic should be a general. Okay, now using that I need to build my tool. Okay, so this is my web search tool, @tool dev web search, and it will accept a string and it will return the string, of course. Then the doc string says up to date web information via Tavily. Here I'll invoke with my Tavily instance and I'll take the responses in this result. Then if the result is in the form of a dictionary, then I need to properly extract in a proper format. So I need to get the title, the content, if there is any URL, then that URL. Then I'll format that proper response like this: title, then content, then URL. Okay, then I'll return that with the formatted result. Okay, and if there is some error, as we are using an API, so there is a high chance that there might be some error. So that's why for this exception we have. Okay, now I'll simply call that web search tool over here, web search tool. Okay, and I'll use invoke, and I'll simply have to invoke with the query. Okay, query. Done. Now if this snippets starts with that particular web error which I used in that exception part, web error. Then I'll print this, that there is a web error. The error is snippets. I'll pass the snippet and let's say predicting to answer with limited info. Okay. Then again I need to return. We'll simply return our state. Now as there is an error in web, so the output for the web will be a blank string, an empty string, and our next route will be that answer node. That answer node is kind of that fallback node. Okay, if there is any error, we'll use that answer. Sorry, it will be inside a quotation answer. Okay, done. Now let's say there is no let's say there is no issue, so then we'll use that web snippets retrieved, and here I'll provide that first 200 characters. Okay, and then I need to print that we are exiting from this node. Exiting web node. Okay, then simply return that updated state, and the web would be this snippet. So snippets and route would be our answer node. Okay, done. All right, so now for this last node here, so the last node is our this answer node. Okay, so whatever the decision we'll have from router, rag lookup, web search, this answer node is something which will call the answer LLM, and the final answer will be getting from this answer node. So the purpose of this answer node is synthesizes all gathered information, like we have to provide it all the context of like what is happening, like what has happened up to that. Okay, like the all context, all the information of state, everything, so from rag, from web, and it will generate the final coherent answer to the user's query. Okay, so let's build this one. So that's why we'll name it our node 4, which is final answer. Okay, so def answer node, it will take the agent state, and it will return the updated agent state. Okay, all right, again print entering answer node. Okay, and I'll just copy this one and I'll paste it right below it. Okay, now in space of this query, I'll change this name to user query. Okay, all right. Now the main thing about this answer node is that we have to provide it the whole context. So for that, I'll create a empty list, context parts, let's say an empty list. Okay, now if state dot get rag, like if we have come in this answer node from rag, then I need to add the context from that particular state, right? So context parts dot append, here I'll use knowledge knowledge base information, which is this one, right? State of RAG. So ctx not s, so ctx parts. Okay, so if we have come this answer node from this router, that means we have to add the context from our RAG, like not from router, from this RAG lookup, then we have to add the context from our RAG lookup. That's why state of RAG. Okay, then if state.get is web, mean if we have come here from this web search node, then I need to check that if the web search is enabled or not, like that whole logic. So if state is web, not stat, state is web, and not state of web starts with this one, right? Wait a minute, I need to check it first. So in our web search, web search was disabled, web search node entered, so web search was disabled. See, if the web search is not enabled, then what I'm returning this one, that web search was disabled. So let it make it clear. Okay, it's all right. Okay, so web search was disabled. So if I've came in this answer node from web, I'll be getting this starts with, then I'll be getting this statement, right, that web search was disabled. Okay, so I'm using this logic that if the web search is not starting with this web search disabled, mean that the web search is enabled, then I'll be adding that context. Okay, so in my context part, I'll append my web search results. Okay, I need to add it, so plus state of web. Okay, all right, this one is done. Now in context, I'll take the whole context part, so I'll join with ctx. Okay, so now this context hold the A to Z context of as of now whatever happened. Now if not context dot strip, mean if we haven't received any kind of context, then I have to give a default context that no external context was available for this query. Okay, and I have to ask it to try to answer based on general knowledge. Okay, done. Because see, I can't show error to my user, I always have to have some default option. Okay, so after that I need to get my prompt. All right, so this is the prompt that we'll use. So I'll make it here prompt. Okay, so user query and the context. Okay, so please answer the user's question using the provided context. If the context is empty or irrelevant, try to answer based on your general knowledge. Here is my question, here is my context. Provide a helpful, accurate and concise response based on the available information. Okay, done. Now we need to take care of the rest. So print prompt send to answer LLM. Okay, now here, what is the prompt? The prompt is this 500, first 500 character. Then in this ans, I'll store my response. So I'll bring my answer LLM, and here I'll use this simple invoke keyword, and I'll pass my human message in the form of content, which is this prompt. Okay, and of course dot content. Okay, now I need to print another statement as this is the final answer. So final answer is ans 200 characters. Okay, then our job is done. So exiting answer node, and we'll simply return updated state and the message, which is the state of messages. So message, state of message, not only the state of message, and here I'll add my AI message of content of my answer. Okay, so here, so this message will store the ultimate response from our LLM. Okay, now we need to build our graph and we need to compile our graph. Okay, so now we need to build our graph and we need to compile our graph, right? So as you could see that here we have this multiple routing, right? That's from router we have 4 node, from rag lookup we have 2 kind of option, like from router we have 4 kind of option, from rag lookup we have 2 kind of option, and from web search we have 1 option. So to make it smoother, we might define some router helpers. Okay, so I'll use these routing helpers for us to help. From router we have this 4 kind of literal, from rag lookup we have these 2 kind of literal, and from after web we have only 1 literal, which is our answer. Okay, and it will help us to build our graph. Okay, so let's build the graph. Def, let's say, let me give a comment first. So build graph. Okay, and it will be pretty fun to build this whole graph. Okay, now def build our agent. Okay, function simple docstring first, important here, builds and compiles the LangGraph agent. Okay, so LangGraph agent. Okay, all right, now let's say in my G, in this my graph dot graph, I'm calling my state graph. Okay, so I didn't import those, so here I'll import after this Tavily Search from LangGraph, from LangGraph dot graph. I need to import state graph and the end option. Okay, now come right over here, I'll call the graph. Now I have it here, I'll pass my state, agent state. Okay, now I need to add those elements and to build the graph. Okay, so graph dot add our first node. So our first node, what? The route node, right? Route node, and to give it a name we'll use we'll use this router. Okay, now again graph dot add node, we have our rag lookup, so rag lookup, and the node name is this rag node. Okay, then again graph dot graph dot add node, here I'll use this web search. Okay, and the name is simple, our web node. Done. Then the final node is graph dot add node, so add node, here we'll pass our answer, and the node name is answer node. Okay, answer node. Okay, all 4 nodes have been connected. Now I need to set the entry point, so our entry point is this first node, our router, so graph dot set entry point, I'll pass my router, sorry, okay, my router. Now from router I can't add a simple edge because I have multiple conditions, so I need to use graph dot add conditional edges. Okay, now here, like from which node I'll be adding these edges, from this router, so first pass our router, then I need to pass this routing helper, this from router. So from router we have this 4 option, right? That's why I'll pass this from router, then I'll just pass those options. So if the option is rag, then we'll go to this rag lookup, lookup. Okay, if we have web, then we'll use web search, and if we got answer, we'll use answer, and last if we got end, if we got end, we'll use this end node. Okay, done. Now wait, now let's say for the first option, from router we move to this rag lookup. Okay, so then from this rag lookup we also have these 2 kind of option, web search or answer. That's why I'll just copy this one and I'll paste here. Okay, now this one will change from router to rag lookup. Okay, so from rag lookup, this will be after rag. Okay, rag lookup after rag, and here we only need this web search, that's it. So web search and this answer. Okay, web search or this answer. Wait, now I'll copy this again, I'll paste it here. Indentation wrong, so I get a tab. Okay, so now from this rag lookup we have 2 kind of option, one is web search, answer. If we got web search, that's why here I'll use this web search, web search, and here I have to use this after web helper, right? So after web, and here I'll only keep this answer node. That's it. Okay, my all edges is done. Now finally graph dot add edge, a simple edge which will be from answer to this end node. Okay, done. My whole graph's workflow is done now. Okay, now simple agent, I'll call my graph, I'll use this compile function, and here I'll use this check pointer. And now the thing is, all the information about state I am storing in a temporary memory server. I'm not storing in a database, which you can of course, but I'm not storing in a database as of now. So for that I need to import from LangGraph dot, I think, checkpoint dot memory. I'll import memory saver. Okay, and here I'll call it over here, so memory saver. Then simple return the agent. Okay, finally my rag agent, call the function build agent. That's it. Okay, so this will help you to build your whole graph with all the features as per this diagram. Okay, now we need to build the FastAPI entry point, where we need to figure out where we need to set all those API endpoints. Okay, so let's do that. So now for this main.py file, where we'll define our API endpoints, which will be our FastAPI entry point, right? So I'll create a new file over here as main.py. Okay, and enter. And here I'll first enter all those dependencies that I need to use. Okay, so I've imported my OS, time, list, dictionary, any from typing, temp file, FastAPI, execution, status, upload file from FastAPI, then Pydantic, then LangChain component, LangGraph components, and rag agents from our agent module, and add document to vector store from our vector store module. If I see this thing, you see add document, so that will be add document only. Okay, all right, now we need to initialize our FastAPI app. Okay, now we need to initialize our FastAPI application. Okay, so here you could see we have our FastAPI title, our LangGraph rag agent API, description API for the LangGraph powered rag agent with Pinecone and Groq version 1. Okay, now as you have seen in our previous module that we are storing the all conversation and all the application in our temporary that memory saver. Okay, so here in this memory I need to initialize the memory saver as well. Okay, so memory saver, here we go, and I'll give some comments for this. So in memory, it is in memory session manager. Okay, in memory session manager. All right, now after that we need to create those Pydantic model for our API routing. Okay, because we need to create a proper structured Pydantic model for tracing all the event of our agentic workflow, all the proper structure for our query request, structure for our agentic response, and structure for our document upload response. Okay, so here is those pydantic models for our APIs. You could see our trace event. So in this exact format, we will store our trace event information: step, node names, description, details, event type. Now then, for the query request, we will store the session ID, we will store the query, and we will store the enable web search information. For response agent, we will store the response and the trace events. And for document upload response, we will store the message, file name, and our process chunk. Alright, and now we need to define our two endpoint, one for our upload endpoint and one to like having chat endpoint. Okay, so the first API endpoint will be for our document upload endpoint. Okay, so document upload endpoint, and this will be of the type of post method. So app dot, I'll use post, and then I need to define that endpoint. So slash upload hyphen document slash. Okay, and then I need to make sure about the response. So response model, which would be with the type of document upload response. Okay, and I also have to mention the status code. So status code will be in the form of status dot, I had to provide the HTTP 200. So HTTP 200 okay. Okay, all right. So after that, now need to create the function. So async def upload document, and here I need to provide the object, so which will be file, and here I'll use upload file, which is multiple objects. So file of multiple object. Okay, then colon. Now I'll first define the doc string that will define that what this function does. Okay, so this function uploads a PDF document and extract the text and add it to the RAG knowledge base. Okay, so let's do that. So the first thing we need to do, that the file you have uploaded, is it a PDF file or not, because we are only handling with the PDF file. And how we'll check that? We'll use that .pdf we'll use that .pdf extension to check. Okay, so if not file dot file name dot ends with, so ends with what, .pdf. okay, then I'll raise an HTTP execution exception where I'll pass the status code as status dot, I have to pass that 400 bad request. So 400 bad request, this one. Okay, I have two, that's not all right. So after status code, I also need to provide the detail. It would be, let's say, only PDFs files are supported. Okay, let's make it in small case. Details. All right, now after that, we need to store those uploaded document in a temporary file in our local store, in our local application. And why? Because we are using this PDF, like PyPDF loader function, to upload those PDF, and PyPDF loader always needs some file path. Okay, so that's why we'll store them in a temporary file. So with temp file dot, I'll use this name temporary file where I'll pass that delete as false. I don't want to delete them, and the suffix must be PDF. Okay, suffix must be PDF, and I'll store them as temp file. So temp underscore file colon, then I need to extract that. So in file content I am using the await file dot read. So I'm reading the file content first, and then in my tmp file I have to write that content. So tmp file, I'll write that particular file content. Okay, there is some warning. tmp file dot write. tmp file is not defined. Okay, so yeah, this will be tmp file. Okay, sure. All right, so then I need to get that path. Okay, so temp file path is temp file dot name. Okay, so in my temp file path I am storing that particular path. Okay, now I'll just print this statement where I'll use received PDF for upload. Here is that file dot file name. Okay, and to give a proper message, saved temporarily to this one, this tmp file path. Done. All right, so now I have stored that uploaded document in a temporary file path. Now I have to upload this, right? So for that I'll use this try, also except exception as e, and here I'll take the message that I had to provide as not a message. Here I need to print the error first. So error, let's say error processing PDF document, and the error I'll be taking from this e. Okay, now also we can just pass the, you have to raise the error. So raise that HTTP exception error first bracket, where I'll pass the status code in the form of status dot status dot HTTP 400 bad request. Okay, more than 400 bad requests, we should use 500 internal server error. Okay, internal server error. Then in the details again, gaps. In detail I'll use a simple message that failed to process PDF, error will come from this e. Okay, done. Now with exception we can also use this finally we'll use if os dot path dot exists temp file, mean if this temporary file exists. So temporary file, if this exists, I'll simply remove that file. Why? Because I want to clean things up when it's done. Okay, os dot remove and print clean temporary file. Okay, because I don't want to backs up my local store with all those CPU power. Okay, so I'll just store them into a temporary file. I'll upload that to my vector database, and then I'll just clean that space up. Okay, now I need to set this try block. Now the first thing, we need to load, right? So I'll get a loader variable here. I'll call the function of py_pdf loader, where we'll simply pass the path, so temp file path. Okay, then I need to get the documents from here. So documents, to get the document, I'll use loader dot load. Okay, all right, now we'll be having a lots of chunk. So to kind of calculate those chunks, I wanna to calculate those chunks, I first have to initialize with it 0. So total chunks added, let's say 0, then we'll add this. So if documents is there, then I need to get the full text content first. So full text content, it will be like this /n, then I'll join with the doc. Okay, so for doc in my documents, so I'll iterate through my whole document and I'll extract the doc dot page content. Okay, so for doc in documents, the spelling is wrong, that's why. Documents doc dot page content. Okay, and then I need to call the function, right? So I'll call the function this add document, where I'll simply pass my this full text content. Okay, then total chunks added, I'll get the value by this length of my documents. There we go. Okay, now finally we need to return the upload response, right? So return document upload response in a way that a message with f-string as PDF of, let's say, this file dot file name successfully uploaded and indexed. Okay, this thing is done. Now comma second, I need to pass the file name. In file name, I'll simply use file dot file name. Okay, and finally process chunks, which will be my total chunks. Okay, total chunks added. All right, so this will help us to upload a document, store a document, vectorize that, upload that to our Pinecone database, and then get the total chunk. Okay, now we need to define the API endpoint for our chat route, or yeah, for our chat route. Okay, now we need to define the API endpoint for our chat route. So now for this chat endpoint, right? So I'll define, let's say, @app dot, it will also be an post method, so post /chat/. Okay, then here I need to get my response model. So response model will be agent response. Okay, then I need to define the function. So async def, it will be chat with the agent. Okay, and here I need to get the object of query request. So query request of query request. Okay, and why query request? Because here you could see this, we are using this query request because of this pydantic model, and this will help us to get our session ID, query, and enable web search. Okay, and session ID will help us to get our proper agentic trace for each and every user query. Okay, all right. So as I have said, we need to trace each and every workflow of the agent. So I need to initialize an empty list where I'll add and where I'll store the whole agentic trace process, like the whole agent's trace. So for that, let's say a trace event. Okay, so a trace event for front end, and here I'll use this list of trace event. Okay, with initialize with an empty list. All right. Okay, now simple try block, but before that an except. Okay, so except exception. So accept exception as E. All right, and here I'll first import my traceback, and then accept exception as E. I import my traceback, and then I'll call traceback dot, let's say, print our execution. So print executions, and also I need to get my error details. So error details, which would be error during agent invocation. Okay, and I'll get the error message from this E. Okay, then for our server debugging, I need to print what's happening. So error details, and at last I'll raise a simple HTTP error. So HTTP exception, where I'll pass my status, code, which is for sure HTTP 500. Sorry, HTTP 500. There is some. Okay, it should be like this. Sorry, will be status dot now HTTP 500 internal server error. Okay, then in detail I'd want key, this is an internal server error with this message. All right, now I need to define the try block. Okay, now in this try block, the first thing that I'll do, I need to define that my agent's configuration with our thread ID, mean our where we'll store our session ID and our information about our web search, and also need to get our input message. Okay, so for that, let's say, let me give a comment as passing web info into the config for the agent to access. Okay, all right, so what I'll do here, simply a config dictionary, then configure, another one here, thread ID, and here I'll use request dot session ID and comma, and then I need to use my web search enabled. Okay, and this will be request dot enable web search. All right, so this will be my config, and after that in inputs I'll store my message. So my messages, which would be my human message, so human message, where I'll store my content in the form of this request dot the query. Okay, and then I'll simply save this. All right, and then the response I'll store in this final message with an empty string. Okay, and after that some server debugging print statement to see what's happening. So starting agent stream for session. Okay, now which session? This request dot session ID, this one. Okay, all right, here we go. Then another one, here we use web search. Here I'll use simple web search, let's say enabled, and here I'll simply pass the information of request dot enable web search. So this will help me in my local terminal what's happening in each step. Okay, so I'll just give it a comment why I'm printing those statement. So for server side debugging. Okay, so now as I've said earlier that we have to track the whole agent trace, so we can't just have the final output. So we have to track the each and every step of our node, right? So I have to take each and every node output state, everything. So for that we'll run a loop. So let's say for every iteration with every step in with the enumerate of our rag agent dot, if I enable the not enable, I had to use the stream here. So for stream, so rag agent dot stream, which will help us to like get the whole workflow trace. Okay, then here I'll provide the inputs and the config. Okay, then a simple colon, and then I need to define my current node name, which is, let me initialize with none, and then another one is every node's output. So node output state, again initialize with none. Okay, all right, then if it starts with this end, so if the state is end state, so then my current node name would be end. Okay, and the node output state would be this step of end. Okay, this one. So if this and else my current node will be the list of all s with the keys. Okay, and I'll take the first index of it, and same for the node output state. Here I'll keep the state of all our current node name. Okay, then I simply need to get the variable as event description. So for each and every event, like for each and every node, I need to get the event description. So event description, sorry for the spelling. So let's say event description would be like execution node. I need to get that from current node name. Okay, and to get event details, I'll create a blank dictionary, empty dictionary, and initialize an event type where I'll pass generic node execution. Okay, simple. All right, Now I need to add the logic for the routing of my backend API for those 4 nodes, right? So router, um, one is for router, then our rag lookup, then answer, then web search, then end, right? Add this thing. So here you could see we have our router. So this is the logic that we have to use, that if our current node name is router, then in our route decision we are keeping that node output state is our route. Then we have to check for the overridden route if if web search is disabled. Okay, then initial decision and override decision we have to use as per our logic. So node output state dot get initial router decision with our router decision. Then for override reason we need to use node output state dot get router override reason. Okay, then for the override reason we have to define our event description with router initially decided our initial decision, then overridden to route decision because of override decisions. Okay, so like this we have to logically we have to create the proper routing. So create for our rag lookup node, same for our rag sufficiency logic, then for our web search node, then also for our answer, and finally our end node. Okay, so after that we need to add our every event to our trace event for frontend, that empty list, right? So I'll use this like trace events for frontend dot append. Okay, then I'll use my trace event. So trace event where I'll pass the step would be I+1 for each and every iteration. Okay, then for node name I need to use my current node name. Okay, then description for event description, so event description, and details for that I'll use my event details, and event type, so I'll use event type. All right, and I need another to close this bracket. So okay, this has been wrong. It will be first bracket and I should close that. Okay, now it's done. Now after that we need to get the final state from the last yielded item in the stream. Okay, so for that I'll just simply paste the logic over here. So here you could see I think there is some indentation error. Just let me fix that. So all right, trace events. All right, okay, so here I have taking, so here I am taking this final actual state dictionary. Okay, for every step I'm taking, if my node is the end node, then I'm taking that my final actual state is this end node, otherwise I'm taking all the step. Okay, then for every step and messages final actual state directory is exist, then for every message I'm reversing the message to get the latest AI message from that to extract my final content. Okay, then the final content is being stored in this final message. Okay, so if not final message, I mean if I haven't got any final message, then I'll be showing this simple error HTTP execution raise a simple error of 500 internal server error. Okay, otherwise this is the final message of agent stream ended. So return with the agent response final message with the trace events, our whole trace event throughout from start node to our end node A to Z workflow. Alright, so that's how it will work, and that's it. Our chat endpoint is done, and to test this I'll simply bring this one health to this health endpoint to check so our server health is okay. I'll bring it over here so that we can test it whenever we want. Okay, right, so now that we are done with our FastAPI backend API route, so now we need to test them. Okay, so for test I'll first get inside my backend directory and I'll run the application as uvcorn with the main file of my app and my FastAPI server name is app. So uvcorn main app reload, so that whatever changes I make it should reload automatically. Reload. Okay, I'll enter, and here is my uvcorn running at this. Okay, now I'll copy this. I'll come to my Postman to check every API route. Now here I'll create a new blank collection. I'll name it, so let's say agent bot, enter, and here I'll add a request to check the health of my API route. So here I'll paste this /HELTH. Okay, I should get a status okay. So I'll test it. Now it's okay. Okay, it just took some time for this application startup. Okay, now you see 200. Okay, now it's working. All right, I'll just change its name as health check. Okay, now we need to test our other route, so add request, another request, and here I'll check it as chat route. Okay, here I'll paste this. Now this one health. Now I'll cut this health. I'll use this chat endpoint, and this will be a post method. Now to use it, I'll use this body raw with proper JSON structure. Okay, now here I'll use this test session 001, which is my session ID, and my query will be what is the capital of France, and I am enabling the web search. Okay, send. Let's see what there is saying. Internal server error in memory server.get tuple. Alright, so there is some error related to this memory saver. So where have I used memory saver? I need to find. So it's alright. This is memory checkpointer, memory saver have a function, right? So I need to use it. Okay, then I'll run this again to see. Alright, so here is saying another error. I need to fix that as well. It's saying during agent invocation route there is some problem in my route. So agent.py line 270. If I go there, return route. So this route is returning from my first node, route node. Okay, so this is what I am kind of returning, and just saying key error route, and here I'm returning message router. It will be route. Okay, all right, Now it should work. Alright, so here you see the result. The capital of France is Paris. Step 1, router decided RAG based on initial query analysis, router decision. Then the first step is RAG. So in this RAG, it's saying that RAG lookup performed, content found and deemed sufficient, proceeding to answer. That shouldn't be the case. Okay, so the capital of France is Paris. All right, so now this working. Now what? All right, so now we have to check our Pinecone Vector database. Okay, here if I refresh this, you could see that we have our RAG index been created over here. Okay, which as of now has 0 record. Now we'll insert something. So now for our another API route, which will be that upload document, right? So here I'll change it to upload document. It will be a post method. I'll paste that. Now in the body, I'll choose the from data. I'll choose this text to file, and I'll enter file. And here I need to select some files. Okay, let's say I'll select this plant epidemiology PDF. Okay, now I'll send to upload all my information to my Pinecone database. Okay, so send. Let's see what is showing in my terminal. See, receive PDF for upload, plant epidemiology, successfully added chunks to Pinecone vector store, cleaned up temporarily. Okay, so now let's visit our Pinecone. I'll refresh the page, and what happened? Yeah, see, record count 8. Okay, so how many chunk have we got? So in my Pinecone, you could see we got around 4 chunk because the paper is pretty small. Okay, so yeah, now let us ask some question related to this. So in my chat route, I'll copy this and I'll comment it out. Here I'll use another one. I'll use test session 2, and I'll ask a question about what is plant epidemiology. All right, I'll say send. See, plant epidemiology is the study of how plant disease is spread and can be predicted or prevented. And the trace event, step 1, router. Step 2, RAG lookup. RAG lookup performed, content found and deemed to be. It will be seemed like there is some spelling error. Sufficient, proceeding to answer, details, everything. Okay, RAG action, then our answer node. Alright, so it's working. Now let us create the front end for this. Okay, I'll save this route first. Alright, so now let's create this Streamlit front end. So now for the front end, I have added this front end folder. Okay, I've also added the requirement.txt for our front end, Streamlit request python.env and UUID for our individual session ID. And here we have our session manager that will help us to manage our session, so that even after having a lots of conversation, we should also see our previous conversation as well. Okay, and this will help you with that module. And then we have our UI components.py, where we have this 5 kind of module for our display header, rendering our document upload section, through which we'll be able to upload our documents. Then our rendering our agent setting section, like to enable our web search, all those that particular feature. Then we have our display chat history section and our display trace event module. Okay, here you could see we have renders the detailed agent workflow trace in an expandable section, uses icon and conditional styling for better readability. Okay, so this dropship will help with this icon map for each and every node, and this will help us to trace and showcase the whole agent's workflow properly. Okay, now see, this is for the display header where renders the main title and introductory markdown, and this will be for our rendering document upload section. Okay, where we'll simply render the UI for our uploading PDF documents to our knowledge base. Okay, I am not explaining each line by line because we have done this multiple time in our channel. Okay, then again our render agent setting section, for this simply web enable search. As last, this display chat section. Okay, then we have in this config.py we are taking this FastAPI based URL from our .env file, so that if in future you want to deploy this application, you just have to add your backend route, mean your backend URL in just FastAPI based URL in your .env file. Okay, and otherwise for your development mode you can use this by default 8000 port. And in this backend API we have these two functions that will handle our upload document to backend API and this chat with backend agent API. Okay, see, FastAPI base URL / chat and FastAPI base URL / upload document. Okay, so that's being said, the last one is this app.py, which is our Streamlit entry point, where we'll merge each and every module, and which is the main function to run the Streamlit application. Okay, so yeah, that's being said, I'll just simply run this front end to test you, to give you the final test, which will be Streamlit run app.py. All right, okay, so let us ask some question that we are asking in our Postman. So see, diabetes is not mentioned in the provided context, which appears to be related to plant epidemiology. Mean the context app provided, that was a plant epidemiology, so of course diabetes wasn't there. So as our enable web search is on, so it just went to web and it has given me some basic answer. Okay, so if I see the trace, you see, then I'll simply add a new document over here, browse file. Let's say I'm adding this, which one should I do? Let's say this diabetes PDF. Okay, loaded that. We click onto this upload, and you could see in the terminal of this backend it's saying retrieve PDF for upload document diabetes.pdf successfully added chunks to Pinecone vector store. And previously we had only this 8 record count. Now if I refresh this, we have 8. Why is not increasing? See, 20. So you have added 12 more chunks to it. Okay, now I'll just copy this link from this Microsoft to this Google Chrome. Okay, all right, so here I'll use that what do you mean by diabetes. See, diabetes is a chronic metabolic disorder characterized by high level of sugar in the blood. Also say, let's see the trace. There we go, rag. Sufficient relevant info found in the knowledge base. retrieve content summary, this, then answer this one. Okay, so yeah, that was what we have to do. And yeah,